Okay, as promised, I said I would finish the graphing, the chapter 5.1 graphing quadratic functions where b is 0. I wanted to do letter D with you. There is no E. I don't know why I said E. I wanted to do letter D because it also is a fraction. So A is 1/2. B is nothing because there's no bx in the middle. C is going to be the -3. When b is 0, the vertex will always be the c value, so 0, -3. Let's plot that and label it. And this parabola is going to open up because the a is positive. Now we're going to go ahead and do a table of values. Now the table of values, just like before with the 1/3, you will not want it to be 1 and 2. Well, 2 will work out okay, but 1 won't, because 1 squared would be 1, and a half of that would give you a half, which you don't really want any fractional amounts. 2 works fine, though, because 2 squared is 4, and when you take a half of something, it's like dividing by 2. So we can use 2 for our x, and it's going to be y equals 1/2 times 2 squared minus 3. 2 squared is 4. Taking a half is like dividing by 2, so 4 divided by 2 is 2, so y equals 2 minus 3. You can use additive inverse if you want, otherwise just -1. So 2, -1 is the ordered pair. Go ahead and plot that. So 2, -1 is our ordered pair. Let's write that, 2, -1. And then we're going to go ahead and reflect that. So this ordered pair is 2 from the axis of symmetry, and I forgot to draw that axis of symmetry in. The axis of symmetry is that imaginary line that passes through the vertex, and so therefore it crosses the x-axis at 0, so the equation is x equals 0. And then we're going to reflect over the axis of symmetry. We'll 2 to the right this way, so now we go 2 to the left. That's going to be -2, -1. And then we're going to go ahead and try another ordered pair, x value to get another ordered pair. Again, we want something that's divisible by 2 once we've squared it. So if we went to 3 squared would be 9. That's not evenly divisible by 2. Then if we went to 4 squared is 16, which if you divide that by 2, it's 8. So 4 is going to work nicely. And we've got y equals 1/2 times 4 squared minus 3. 4 squared is 16. Half of that is 8. So y equals 8 minus 3. So y equals 5. So the ordered pair is 4, 5. And we plot it. 4, 5. Label it. And we're going to connect this right side, the points on the right side of the parabola together. Then we're going to reflect that over the axis of symmetry. It's 1, 2, 3, 4 from the axis of symmetry on the right. Go 4 to the left, 2, 3, 4, plot a point, which should be -4, 5. Now we're going to connect the vertex to these two pairs, and you have your parabola. Now this parabola and the one previous are wider than the parent function, because when the absolute value of a, is less than 1, meaning it's a proper fraction. So remember, absolute value just allows you to have both positives and negatives. So it'll end up being a proper fraction. The parabola is wider than the parent function. So when you have a fractional a, you can expect a parabola that's going to be wider than the parent function. This is just more of a number sense kind of idea. It's not something you're going to use to actually draw the figure, but it is something you can use to check to see if you did draw the figure correctly. Anyway, I hope this little video and the one previously has helped you. Make sure that you do the assignment once you have completed watching this video. Thank you.